Okay, this video is about statistical process control charts, and this is how you construct xbar and R charts, and we're going to be constructing these because the data that we have is continuous data. So what we have in our xbar worksheet is some tread wear. This is looking at tires. And what we do is that after we manufacture a tire, we randomly grab a sample. So in this case, we grab a sample, think of these as days. And our observations per sample is 3. So every day we grab 3 tires randomly. And then we put them through an accelerated wear test, and then we measure the wear on the tires. So this is some unit of measure of wear. So, how can I use this in plot to see if my process is in control or not? Because this data is numbers, continuous data, I use xbar and R charts. So for the xbar chart, I certainly need to calculate xbar, which is the sample average. I also need to calculate the range. There's not a range function, but there's a max function and a min function, and the range is equal to the max minus the min. And I'm not going to show too many decimals, I'm going to leave it like that. So ultimately what I'm trying to plot is an xbar chart. Ultimately I'm trying to plot this, and in addition to that, a separate chart that is a range chart. This. However, the purpose of the control charts are to identify if a process is in control or not. In control means that we're within our control limits, or there's no hidden or underlying pattern of the data, assignable costs. So I'm going to be able to generate control limits. Let's do that. To generate the control limits, I need to know what bar is, and that's the average of all my averages. I also need R bar, which is the average of my ranges. And now I need some constants. I need A2, D3, D4, and I'm going to go ahead and grab lowercase d2. Now they are a function. I'm actually going to scoot those down once. They are a function of observations per sample, which for this problem is 3. Every sample is made up of 3 observations. So I need to go grab these constants for these. And in the book, if you look in chapter 13, it gives you a table. Table 13.7 is where you can grab these constants. But I don't want to use that table, especially because that table doesn't have D2 in it. So I'm going to go do a search for control chart constant table. And I'm going to go ahead and take a chance and grab this first one. And that's perfect. So this is identical to what's ever in any textbook. So the observations per sample, it's not really called sample size, it's the observations per sample is 3. So A2 is 1.023. D3 is 0, D4 is 2.574, and lowercase d2, which I'll need later, is 1.693. Okay, so the reason I need those is I need to calculate my control limits. The upper control limit and the lower control limit for the X bar chart is equal to the center line, which is X bar bar, plus A2 times R bar. And for the lower control limit, it's equal to X bar bar minus A2 times R bar. That's for that. And then also we have to build a range chart. So the upper control limit for that and the lower control limit for that. The upper control limit is equal to D4 times R bar. And this is equal to D3, which is 0, but we'll go ahead and put the formula in, even though we know what the answer is going to be, times R bar. Okay, so those, now I'm going to want to build a graph, so I'm going to go ahead and use columns L, M, N, and O to put those over here. So here's for the X bar, the upper, I'll do this order. Lower control limit, X bar, upper control limit, X bar, lower control limit R, upper control limit there. And then I'm just going to point to them. This is this one. I'm going to put some dollar signs around it. So when I copy it down, this is this one, dollar signs. And again, I don't really need to see all those decimals. I'm going to show whole numbers. Yeah. Copy those down for as many observations we have, which is 30. Alright. Whoop, this one is wrong. That needs to be referencing this. Okay, now I can build my control charts. I'm going to build the X bar first, so I'm going to click right in the middle, left click and drag, and then hold the control button down. So I'm not touching the keyboard. Now I'm going to hit the control button and then left click in the middle, drag, and that allows you to grab data that's not attached and build my line chart. And if you want the lines like that, that's probably okay. I'm going to stay without the lines like that. Do the same thing for the range chart. Grab the data. Hold the control key down. Go grab the lower and upper control limits for the range chart. Build another graph. Well, yeah. That one. Generally, when you report these or you see these, they're underneath each other. Let me zoom out a little bit. That way you put them on roughly the same time slice. And the answer is, since we don't have any of our data points outside the control limits, we can say the process is in control. It doesn't mean we don't have variability. It just means that the variability is not assignable. There's other rules to identify assignable cause. For the class, we're just going to look at the control limits as our measure. Okay, that's how you construct a X bar R charts.